Hello everybody, welcome to the first video in the series of Physics at Home for Circuits and Light. In this video, we are gonna just do some general measurements using a multimeter. A multimeter is a device that you can buy for $5, $10, something like that, and which comes in pretty handy if you wanna, for example, make sure that if some device stops working at home, then just check if the battery is gone out or if something else is going on. So just to that's one of the tools to just have it handy at home. Now every multimeter is gonna come with leads. Okay, so these are two leads for this multimeter. One is red and one is black, and usually red is what is they call as an input, and then this one is an output. Okay, now this multimeter has 3 ports. Okay, now the first 2 ports at the bottom here are going to be useful for us throughout this series. Occasionally we might encounter this guy, but I don't foresee it. So let's see what are these 2 ports. So this one here, it says COM, or it stands for common. So this is the port where you plug in the output or the black terminal lead. And then this is, you can see there is a V and there is a sigma sign, MA. So this port here is useful for measuring voltage, resistance and current. Okay, so the red lead goes in here. Make sure. Alright, so we got it in now. So now this multimeter is ready for checking some doing some measurements. And one thing that we're gonna do is measure the resistance of this resistor. Okay, now on this multimeter, this is the LCD display, and this one is called as a function and range selector. So there are different things that we can measure on this multimeter. As we already saw, voltage, resistance and current. And voltage, there are 2 kinds that we can measure: a DC voltage and an AC voltage. So this range selector or function selector here, it has a little dot here on which I put a permanent marker to make sure to know that where this one is supposed to be pointing, and then you can turn it wherever you want, whichever function and range you want to select. So this was off, and I want to measure resistance, and resistance is right here, and this green section, okay, so from 200 to 2000, so which is 2 million ohms. This is the range of resistances that we can measure. So I'm going to turn this and bring it here to 200. Okay, so right now I've selected 200. Now just to make sure that this is indeed, these leads are pretty good, meaning they don't have as much resistance in it. So what you can do is just connect the 2 together. Okay. So right now I see there is a little bit of resistance between these leads, which is about 2 ohms, and that's understandable. That is acceptable range. It's really small, and the resistors that we're going to use eventually in this series of videos, the resistance is going to be really high, and then these leads, they're going to offer really they won't the resistance of these leads won't affect as much. Okay, so let's see if how much is the resistance of this one. So I don't know if it is 200 or higher than that, but let's see. Okay, so right now 1 here would mean that this is a really resistance higher than 200. Okay, if the resistance is lower than 200, like it was in this case, then the display shows the number. Okay, but as soon as I don't short these two leads together, then now suddenly it's measuring the resistance between, the air in between here. So anyway, so one end of the resistor, I'm going to hold it like this, and then the other end right here. And you can see it looks like this is more than 200. So let me bring this to 2000 now. Let's see. Okay, so 808 ohms. That is the resistance. So this is more than 200, but less than 2000. So the range of resistances that this can measure is, up to 2000. Now I want you to, what I'm going to do now, actually, I'm going to use these connecting cables. So the red connecting cable, I'm gonna using the alligator. Like if you open it, it has teeth like alligators. And then hook it up here or connect it here. Now the other end is open of this connector. And then the black one, I'm gonna put it here. Connect it here. And the other end is open. So all I just did was, just extend these leads by these connecting wires, okay, or these connectors. Now I'm gonna hold this end here and then this end, the black. Okay, so 807. Okay, so it's slightly different than last one, but it's okay, right? 807, 808 is the same resistance before. So now what I want you to see is what happens if I change the range. Okay, so right now it's up to 2000. If I change it to 20,000, you can see now it says 0.81. So now it's 0.81 K. Okay, so let me bring this closer so maybe you can see. So it says 20K on this. Okay, so it's 20,000 and it's telling me that it is 0.81 thousand, meaning 0.81 times 1000 would make it about 810, right? So which was close to 808 earlier, or 807 as we saw. So these ranges here, if it's measuring the same resistance as before, but it is just moving the decimal place. So right now the decimal place is at 808, and then decimal and then 000, right? Now as soon as I move this here, now it's measuring in thousands. Okay, so now it's 0.81 thousand would mean about 810, right? Now if I move it further here, now it's still 0.8 thousand, but like close to 800. So this is just increasing the range of resistance that you can measure. Okay, but I want to get a good number here, so 800, up to at least to the last ohm. I want to know how much is the resistance. All right, so this is how you can select the function, which was the resistance, and also select the range. All right, so now that we are done with this, now let's measure the voltage of this battery. Okay, so now I want to disconnect the resistor, and this battery is supposed to be 9 volt. Okay, so every time you buy a battery, and whatever it says 9 volt, 1.5 volts, 6 volts, something like this guy. This is a 6 volt battery. So any one of these batteries, as soon as the voltage drops less than 9 or whatever is specified, then at that point of time the battery is going dead. Okay, so it's close to getting dead. But so let's see, this battery indeed is 9 or above, okay, as in volts. So now we are done with the ohm or resistance function. Now we want to look at voltage. Now this is a DC, a direct current power supply or battery. So we want to now select the DC voltage function, which is right here, and we are expecting this to be 9 volts, correct? And we go from 200 milli, okay, so about 0.2 volts range to 2 volts range to 20, 200 and 1000 volts. Okay, so these are the different ranges. So let me see, if I go to 20, now this multimeter is equipped to measure up to 20 volts. Now since this is 9 volt, then I want to, if I hook these two over here, then it should be able to show 9 or higher number if the battery is not dying already. So now this battery, there are two terminals. This is a positive, which is the smaller of the two ports here, or terminals here, and negative would be this larger one. Okay, so remember when we said that this is the output, black or negative. So connect negative here, and then this one is supposed to go to the positive or input in here. Okay, so this one I can hook it up like this. Okay. All right, so now you can see it's 9.28 volts. All right, so this battery is still good, even though I used it more than 6 months now. So up to 20 volts, I could get that number. If I move this range, so now watch what happens to the decimal point. Okay, so earlier I could see up to 3 or second decimal, but if I move it here, now I can see only up to the first decimal. Okay, and if I move this one farther, then I don't get anything after 9. Right, so that's what the range would mean. Okay, so at 20 I can get up to second decimal. If I go to 1000 m would mean milli, then 2000 milli is 2 volts. So if I select 2 volts, then it's going to show me 1, as we understand that 1 would mean that you are above the range, or whatever that you're measuring is more or larger than the range that you have selected. So at 2 volts, it's the maximum it could measure, but we are 9 volts, so it's higher than 2, and that's why it's going to show 1 here. All right, so what, 9.26, 9.27, something like that. All right, so we were able to measure resistance. Now we also measured voltage. Now there is one more thing that we want to measure is current. Okay, just to make sure that all the functions that we need on this multimeter are working. Okay, now to measure the current, okay, I'm gonna bring back the resistor. Okay, now what I need to do here is connect it like this. All right, so have my connector red here, then one end on this side. Okay, keep this one connected to the negative. All right, so this is what is happening, that right now I don't have a full circuit, in the sense that this red here needs to be connected to the other end. So if I do that, then the current will be able to flow through this battery, and then through the resistor, through this multimeter, and back to the battery, right? Not only that, but we have to go to A, and this is a DC supply, so we need a DC current measurement. So let me turn this. Now I don't know how much is going to be current, so I'm going to put it somewhere here. Okay, so this is the 2000 micro, and that would mean 2 milliamps of current. So that's the limit. Okay, all right, so now I need to do is this lead here, just touch the resistor, and you're going to see a number here. Oh, it's more than 2 milli. Okay, maybe up to 20 milli. Let's see. All right, 10.96 m, right, milliamps. All right, so there is a 10.96 milliamps of current flowing through this circuit here. And if I again move this farther out, now I'm gonna, earlier I could see second decimal, probably now I'm gonna see only up to the first decimal, as you can see. Yeah, 11. So 10.96 is pretty close to 11, so it rounded it off. So it gives me 11 milliamps of current. But I want to know a little bit more, a second decimal point. So right there. Oops. All right. So yeah. So about 11 milliamps, 11.02 milliamps. That is the current flowing through. And it could switch a little bit, like as you can see it was 10.96 but now it's 11, so within 5 or 0.05 milliamps, it's swinging up and down, so which is okay. It's not like it was 10 and then it was 15 milliamps and then back to 5 milliamps or something like that. So this multimeter is still reliable. Okay, and then all the three functionalities that we need are fine in this here. Okay, now just as a preview of things to come, this battery was supposed to be 9.28 volts, correct? So 9.28, I'm going to get my calculator here. So 9.28 divided by the resistor was about 808, right? So 808, and that gives me 0.0115 or 11.5 milliamps of current. This, as I believe maybe you would have guessed by now, that what I did just now is voltage divided by resistance gives me the current. This comes from Ohm's law. But again, we'll go into the details of the Ohm's law later on. But we were expecting 11.5 milliamps of current and we are getting 11.06. Okay, so remember, because of the leads here and these connecting wires, the resistance, the total resistance here is slightly more than 808, and that's why we get a little bit lower current than they expected. Okay, so there it is, all of the pieces that we need as we go forward in this series of videos are right here. Okay, hope you enjoyed the video, and next week we're going to talk about Kirchhoff's laws.